Right, going to look at addition and subtraction of fractions today. The key thing that we first look at when we approach a fraction, we'll deal with this one first. The first question we ask ourselves is, do they have a common denominator? Because if they do, life is a lot simpler. The first one here, if I work down the page, so I put an equals there, because both of these are terms in sixths, so they've got a 6 on the bottom line, the answer automatically is going to have a 6 on the bottom line. That's the currency it's dealing in, and I don't have a problem. So I write that in. Now I can effectively forget about that and just concentrate on the 5 minus 1. Now I wouldn't in practice bother writing 5 minus 1 on the top, because I happen to know on a good day 5 minus 1 equals 4. So that's my answer. Now because this is a fractions, I simplify if I can. That's a general rule. 4 over 6 does simplify down to 2 over 3. So I'll stop it there. And I'm trying to have my equal signs in a vertical stack, so I'll put a line. Now, I approach number 2. Number 2 has got a problem because the bottom lines are not the same, 3 and 6. Now, what I can do though is I can say, well, if I don't bother changing the 5 over 6 and just leave it like that, I can make a 6th on the bottom line if I go 2 times 3. That gives me a 6 on the bottom line of the other one. That's fine. If I do that to the bottom line, because I want equivalent fractions, I must times 2 on the top line, so that gives me 10. Now I have rewritten the problem. The plus is still the plus. The 5 over 6 actually hasn't changed. The 10 over 3 is now expressed in sixths, but this is just an equivalent fraction. Now I've got the common bottom line. I'm like I was in the previous one. The bottom line will be 6. I go to the top line and I got to go 10 plus 5. This time it's a plus. So that gives me 15 over 6. That's not great, 5. Now that does simplify. Divide both by 3 and I get 5 over 2. I'm going to leave it as an overloaded fraction. I could write that as 2.5 if I wanted. Now, if I go to number 3 though, the bottom lines are different, so the denominators are different, but here I can't just multiply 3 to make 4 or 4 to make 3. It's not tidy, so I'm going to have to use the most extreme option. So there's various ways of setting it up, but if I take that 3 from the bottom of 1, I times it by 3, times by 3 there. If I colour code this, if I take that 4 on the bottom of the other fraction and I go 4 times there, 4 times there. Now, what I'm redoing, I'm rewriting the fraction, so the plus is still in. It's still 2 fractions to be added together. This is just, but 4 times 3 both times is 12. This is a major leap forward because now my bottom line is 12, so I could even write down the bottom line for my final answer. It's going to be a number of twelfths. I look now at the top line. 4 times 2 is 8, so that's under control. 1 times 3 is 3. On the top line of my 12ths, because this is a plus, so I go 8 plus 3. Now that goes to 11 over 12, or 11 twelfths, and there is no simplification that I can do. So that's got the number examples out of the way. I'm going to dive to the next sheet. Going well. I've got some algebraic ones following a similar sort of pattern, so I'm going to approach them very similarly. So if we do this one, do it in this order, 1, 2, 3. And so if I attack the first one is good and tidy. The bottom line, the denominators are common, they're both 6s, so I know on the bottom line I'm going to have a 6. I can sort of ignore the 6s now, focus on the top line. So the top line is made up of this. 5x on one fraction, there's a minus in between, and there's an x on the top of the other fraction. Go down to my tidied up version, the 6 stays a 6, I'm not tampering with that. 5 times some number, if I'm looking at this bit, 5 times some number minus 1 lot of that number, that leaves me with 4x. Now, arguably, I've done the subtraction and now I've only got one fraction, but this can be simplified. I've got nothing to cancel against the x, so it stays right where it is, but 4 over 6 simplifies down to 2 on the top line and 3 on the bottom line. So my best way of writing that would be like that. If I go to the second one, now 6 and 2 have got a good relationship. If I times 2 by 3, and I must treat it top and bottom, I can get both of these fractions written with a 6 on the bottom line. The minors are still sitting there. I haven't done anything with the minors in practice, but 2 times 3, that gives me that 6. X times 3 I would write traditionally as 3x, always put the constant before the variable, that's a bit of a rule. I haven't dealt with the minors yet, but now I've got the common bottom line. These are both 6's, so in knowing my answer, the bottom line is going to be 6. On the top line, and this is the line that I wouldn't normally write, but I will this time, 5x minus 3x. Now these are like terms, they can be combined. 5 minus 3 on a good day is 2, so I've got 2 lots of x. Now, again, this one does simplify, much like the last one, very similarly. There's nothing to cancel against the x, so it stays firmly on the top line, but 2 over 6 is the same as 1 over 3. Now I could put 1 there and 3 there, but that 1, there's a rubber outer on this, I'm not sure if I can work it. Yeah, I don't need the 1, so I rub it out. And I'll leave it like this. The final one, which is probably the most work, is this example here. I can't play a similar trick that I did in number 2. I can't multiply 5 to get 3 or multiply 3 to get 5. So I'm stuck with that cross-multiplying looking thing. So I take the bottom of one line, one fraction. I'm going to go for 15s here. 3 5s are 15. I'm going to times by 3 there. I'm going to times by 3 there. Change colours. I take the bottom line of my other fraction, which is, and I'm going to go times 5 there and times 5 or 5 times there. Now, when I rewrite them, the plus is still here, and I'm just rewriting the problem. Now 5 times 3 is 15, and 3 times 5 is 15. So that was always going to give me 15 on the bottom line. That was the whole point, 3 times 5. Now I've got to be careful along the top line. Here I've got 5 times 5x, which is 25 lots of x. Step over the plus in the meantime and just look at this part here. 4x times 3, well, I've got a number of x's, and I happen to know 4 3s are 12. So I write that like that. Now, I'm nearly done. I'm closing in. So I go equals. The bottom line is going to be 15. That's decided. Again, this is the redundant line, 25x plus 12x. I would normally just do this job in my head, and I'm going to say, well, 25 and 12 on a good day would be 37. I've got that's x's on the top line, and I've got a 15 on the bottom line. Now looking at that, I'm thinking I can't simplify, so I'm stopping right there. Okay, hope that helps.